So in this video we're going to talk about using half-life to build a model and how we can use it to answer some questions. So we're going to look at the isotope of iodine-123, which has a half-life of 13 hours. I'm going to use this form of the model, y equals ab to the t, and it's really slick how we can use half-life to build the model. Because what I can do is I can say, okay, well, I've got my initial A, its half-life, so I want it to be multiplied by a half, but not every hour. I want it to be multiplied by half every 13 hours, so I compensate for that in the exponent and make it t over 13. And there's my model. For any initial, I now have my model for iodine-123. So the first problem says, how long does it take for 1,000 milligrams to decay down to 100? So I'm going to put in 1,000 for my initial, 100 for my final after t, and now I'm solving for t. First step, divide both sides by 1,000. And over here, cancel out a couple zeros, I get 1/10 or 0.1. So I have 0.1 equals 1/2 to the t over 13. Here's where we're going to employ log or natural log. Since I'm kind of short on space, I'm going to use natural log, which allows me to pull the exponent out front. So I have natural log of 0.1 equals t over 13, natural log of 1/2. I'm going to multiply both sides by 13, so that cancels it out over there and puts it over here, and divide both sides by ln of 1/2. So there is how long it's going to take. Now what would be nice is if we had this as a number, so we will use our calculator to help us out there. And so I've got that it's going to be 13 times ln of 0.1, close my parentheses, divided by ln of 1/2. And it's going to take about 43.2 hours, let's say. So 43.2 hours. And I put in one more question because there's another way you'll see this asked. And say we didn't have this question here, so we just answered this one, but let's ignore it for a little bit. How long does it take for it to decay to 10%, or how long until 10% is left? Now it may seem like there's not enough information, but if we start to set this up using the model that we found earlier, I know that my initial's A, it's 1/2 to the t over 13, and I want to know when there's 10% left. So that's 10%, 0.1 of my initial. So the first thing I'm going to do is divide both sides by A. This is really cool. What's going to happen? We have 0.1 equals 1/2 to the t over 13. That should look familiar. That was the same problem we just solved. So there's two different ways of asking the question. One, they could give you the initial and ask how long it takes to go down to a certain amount, or they could just say how long until a certain percent is left, because there is actually enough information in that case.